Slide 1 presented by Irandi. This project was completed by Irandi Gonzalez, Maya Greeny, and Maverick Bonet. We present Region 8 Lower Colorado Basin, which includes the Grand Canyon, Petrified Forest, Joshua Tree, and Saguaro National Parks.
Slide 2, Maya. The geologic formation of the Lower Colorado Basin, shown in Figure 2, is the result of the laramide orogeny, which was a convergence boundary, the San Andreas, which is a transformed boundary, the Colorado Plateau, the Basin Range, and the Colorado River. The book Western Mesozoic Orogenies by Historical Geology explains that in the Mesozoic era, the west coast of North America was dominated by subduction. The Kahlua Plate and the Farallon Plate were once hot and young. This caused flat slab subduction, which led to the laramide orogeny. Figure 3 provides a visual. A flat slab subduction essentially is a prolonged narrowing of the curvature between two tectonic plates. Typically, a normal subduction is about 30 degrees, and a flat slab subduction is about 5 degrees. The article, Laramide Orogeny by Britannica, explains that the laramide orogeny is a polyphase made by different pulses of deformation differing in age and intensity from one place to another in western North America. This affected the geologic formation of all the national parks within the Lower Colorado Basin region. In his YouTube video, Geology of Joshua Tree National Park, Jay Chapman describes the San Andreas, as shown in Figure 4, as a transformed boundary between the North American and Pacific plates, and it is not a singular fault, but a composition of many faults and small crustal blocks between the faults in a wide zone of distributed deformation. The Western Mesozoic Orogenies book by Historical Geology discusses how, 30 million years ago, the mid-ocean ridge subduction contributed to the formation of the San Andreas fault system and the Basin and Range geologic province. It also explains how the Basin and Range covers a grand portion of the southwest United States, extending to western Mexico, and it is characterized as a divergent boundary where deformation is visible. Joshua Tree, Petrified Forest, and Saguaro National Parks lie within the San Andreas Fault. Moreover, the article Geodiversity Atlas, Southern Colorado Plateau Network Index by the NPS informs that the Colorado Plateau sits in the center of the southwest, and that it is a tall standing crustal blocks of undeformed strata, displaying step-like folds known as monoclines, dome-like intrusions known as igneous laccoliths, normal faults, and volcanoes. Essentially, the Colorado Plateau is like a pie that got pulled apart, but for whatever reason, one piece of this pie stayed together in one piece and rose up. The Colorado Plateau lies within the Grand Canyon and the Petrified Forest National Parks, and as said by the article Colorado River by Britannica, the Colorado River comes down from the Rockies and then down through the Colorado Plateau.
Hi, my name is Maverick and I'll be presenting for the Grand Canyon. The Grand Canyon was established as a national park in 1919 according to the article Geology of the Grand Canyon by the National Park Service. They also state that between 1.7 and 1.8 billion years ago, the Yavapai Mutsal orogeny formed the metamorphic rocks underlying the Grand Canyon. This period saw the creation of a mountain chain resembling the Himalayas. Over time, these mountains were gradually worn down by erosion, including the effects of snowball earth conditions. Today, according to How the Grand Canyon Was Formed, a PBS YouTube video, the only remaining traces of this ancient mountain range can be found in the Grand Canyon, particularly in the form of schists, which serve as a reminder of the mountain's distant roots. After snowball earth, the glaciers melted, creating oceans that would rise and fall, depositing sand, mud, and ancient seashells, creating limestone, shale, and sandstone. Almost 2 billion years ago came about the formation of the igneous metamorphic rock of the inner gorge. The uplift of this entire region occurred between 70 and 30 million years ago due to plate tectonics, which elevated and rotated the Colorado Plateau about 1.5 degrees. Around 5 to 6 million years ago, the Colorado River started to vastly change through erosion of the landscape, gradually cutting deeper into the terrain throughout millions of years. Combined erosive forces of streams contributed to the widening of the canyon. According to How the Grand Canyon Was Formed by PBS, approximately 6 million years ago, the rushing waters of the Rocky Mountains played a pivotal role in the formation of the Colorado River, which carved out the majestic expanse of the Grand Canyon. Still today, these forces of nature are at work slowly deepening and widening the canyon. The Grand Canyon is so deep due to gravity, rain, and ice that have eroded away the canyon walls, exposing layers of ancient rock, as seen in Figures 7 and 6.
Also located in the Lower Colorado Basin, about 200 kilometers southeast of the Grand Canyon, is the Petrified Forest National Park, as illustrated in Figure 8. According to the article Brief Administrative History by the National Park Service, President Roosevelt created the Petrified National Monument on December 8, 1906, as the mineralized remains of Mesozoic forests were of great scientific interest. However, it wasn't until December 9, 1962, that the park was officially established by Congress as a national park. The Petrified Forest is a result of the Chinle Formation, which was deposited over 200 million years ago. According to the article Geologic Formations by the NPS, the Chinle Formation's fluid deposits are responsible for the colorful Badland Hills, flat-top mesas, and the beautiful Painted Desert. The petrified forest was also influenced by the Vida Hoshi Formation, consisting of a large lake basin from about 8 million years ago. As explained in this article, the Vida Hoshi and Chinle formations may contact an inconformity, representing 192 million years of missing time. The petrified forest is also characterized by years of erosion and deposition. Millions of years contributed to the erosion of most of the Vida Hoshi Formation from the park. In the video Geology of Petrified Forest National Park by Jay Chapman, he explains the colorful hills are the result of ash layers and paleosols from the Chinle Formation. The movement of water with organic and inorganic acids helped distribute elements that gave the soils a colorful appearance. In this process, the Chinle sediments were covered by water, which prevented the oxidation of manganese and iron, giving it its blue and green hues, while the pink, orange, red, and purple hues are the oxidized versions of these compounds, as illustrated in Figure 9. During the Chinle deposition, there were periods when the region was a swamp-like environment, while at other times it was very dry. A. Chapman describes this environment to be potential evidence for a monsoonal paleoclimate, which refers to a climate consisting of yearly changes between rain and drought. Chinle sediments are also visible in the park's petrified logs, illustrated in Figure 10. According to J. Chapman in Geology of Petrified Forest National Park, the sediments in the Chinle Formation were derived from the Triassic continental volcanic arc located in the southwest. These sediments high in silica are what contributed to the fossilization of fallen coniferous trees, in addition to mineral-rich waters that dropped the logs into floodplains, where they were also covered in mud and sands that prevented them from decomposing. Today, these logs have turned into stone where amethyst and jasper of different colors make up the petrified wood, in addition to a type of quartz known as microcrystalline quartz, which forms from silica-rich shell that dehydrates the wood through a process known as permineralization. Finally, during the petrification process, the wood cell walls are fully replaced by silica.
Also located in the Lower Colorado Basin lies Joshua Tree National Park. The articles History and Culture and Park History by MPS say Joshua Tree was first designated a national monument by President Franklin Roosevelt in 1936, and through the Desert Protection Bill, which, as stated in our class book, National Parks, The American Experience by Alfred Runt, is a bill that was passed in 1994 to curb off-road vehicles and expand preservation, which then allowed for the process to grant Joshua Tree National Park status on October 31st, 1994. In his YouTube video, Geology of Joshua Tree National Park, Jay Chapman explains how Joshua Tree is mainly composed of intrusive igneous rocks, which are part of the coastal Calderian batholiths. Calderian batholiths are a system of parallel mountain chains that are a large body of igneous rock that formed below the Earth's surface by the intrusion and solidification of magma. Furthermore, Jay Chapman explains how these Calderian batholiths are the remains of the Mesozoic continental arc and include the Sierra Nevada to the north and the peninsular ranges to the south. These batholiths were once connected, but got sliced in two by the San Andreas Fault. Joshua Tree sits on the San Andreas Fault system, and it cuts in the Eastern Transverse Ranges region, and Joshua Tree orientates east-west due to being rotated by the San Andreas and other faults. The article Geologic Formations, Joshua Tree by MPS, discusses how 270 million years ago, there once existed the supercontinent Pangaea. And at this time, the continental plate collided with the Farallon plate. The dense Farallon plate plunged below the continental plate, and continuous movement of the Earth's crust was heated up by molten liquid, and as a result, it oozed upwards and cooled down below the Earth's surface. These plutonic intrusions are a granitic rock called mantle granite. 100 million years ago, the same magma cooled and hardened into stone, and then a dry, arid climate was established in Joshua Tree during the Pleistocene epoch, which enabled erosion to expose the rock towers seen today in Joshua Tree National Park, as shown in Figure 11. When considering the current and future state of Joshua Tree, the article Joshua Tree Climate Change by MPS explains how, at lower and warmer elevations, fewer seedlings are sprouting, growing, and surviving due to climate change, and how they predict that by 2099, the average annual temperature could increase to 5 degrees Celsius. It is sad to say, but under these conditions, it could eliminate almost all suitable habitat, as shown in Figure 12, by 90%.
Hi, I'm Maverick again, and I'll be presenting the slides for Saguaro National Park. Furthermore, on March 1st, 1993, according to Geology of the Rincon Mountains by the National Park Service, the Rincon Mountain District was designated as the Saguaro National Monument. This was the first national monument established to protect a species of plant, the giant saguaro cactus, as seen in all three figures. Then on October 14th, 1994, the monument was designated a national park, making Saguaro the nation's 52nd national park. According to geologic formations by the National Park Service, about 70 to 75 million years ago, when the Pacific Ocean plate converged with the continental plate, it created several major volcanoes. These volcanoes were then overtaken and covered by a large caldera, expanding some 12 to 15 miles in diameter. Ever since the eruption, the caldera has been vastly eroded. The metamorphic core complex is unlike more common way of mountain formation involving different tectonic factors like compression and uplift. A metamorphic core complex in comparison forms through stretching and lengthening of the crust under various tectonic factors. Also, the Catalina Detachment Fault that snakes its way through Saguaro National Park is where the deeper crystalline metamorphic rocks of the core complex begin to rise along the crack of the fault, and the shallow sedimentary and volcanic rocks are moving down and away, according to the video provided by the U.S. National Park Service. Because of this detachment fault, we can visually see 1.7 billion years ago on the surface of Saguaro. Following the journey of a single zircon crystal found on the surface of Saguaro National Park can tell us so much about past geologic occurrences. According to video by the National Park Service, 1.7 billion years ago, when life forms were first appearing on Earth, the crystal was formed. Around 30 million years ago, the crystals and surrounding rocks began to lift due to the Catalina Detachment Fault, closer to the Earth's surface. Around 20 million years ago, the crystals were 4 to 5 miles from the planet's surface. Other than ancient rocks, according to hydrology in Saguaro National Park by the Saguaro National Park Service, tinajas are also found all throughout Saguaro, which are pools of water that remain full in the hottest and driest months throughout the year. Water at Saguaro National Park is one of the most precious resources for animals to survive. Ancient water and deep underground aquifers keep water all around all year at Saguaro National Park.
In summary, the Lower Colorado Basin National Parks, Grand Canyon, Petrified Forest, Joshua Tree, and Saguaro demonstrate the complexity of this region. From canyons, rivers, deserts, and hills, these parks provide a beautiful outlook on how this region has been shaped throughout millions of years and the impact that the Laramide orogeny, the San Andreas Fault, the Basin and Range, the Colorado Plateau, and the Colorado River have had over its geologic formation. It is important to remember that the Colorado River, illustrated in figures 17 and 18, is critical to the geologic history of this region and its future evolution, especially since the Colorado River has and continues to experience significant impact from the climate change due to drastic changes in yearly precipitation and snow levels. The Nature Conservancy suggests that temperatures in the Colorado River are predicted to rise another 2 to 5 degrees Fahrenheit by 2050, which could reduce river flows by 10 to 40%. This drought presents a major issue to the Colorado River Basin, impacting the natural environment and wildlife of the parks located in this region. Therefore, rapid climate change is something that needs to be addressed in plans for the preservation of natural resources.